So Al-Biruni was measuring which horizon?
The dip angle to the horizon, yeah.
No, not the dip angle to the horizon. I asked which. You said there were several.
Yeah, he was trying to measure the geometric horizon, but...
Oh, he was trying to measure the geometric horizon, but you've made it explicitly clear that it cannot be seen and only exists in maths.
He was trying to measure the geometric horizon.
Yes, I understood that. He's trying to measure a geometric horizon, something that you say we can't see. It's just some point that doesn't demarcate land and sea. It's not a demarcation between land and sea, so how can he possibly be measuring it? I don't really understand how something that cannot be seen and only exists in maths anyway is going to be measured by Al-Biruni. Can you explain that?
Yeah, it's within 5% of the gym
of a horizon that's geometric, that can't be seen. It's in 5% of something that can't be seen.
The geometric horizon is just a position, doesn't demarcate anything, but it's close enough.
So it doesn't demarcate anything, we can't see it, but Al-Biruni was trying to measure it, correct?
Yeah, he was trying to find...
Yeah, so he was trying to measure something that he couldn't see. That makes no sense.
But it was, because he knew it was close to the...
He knew it was close, so he's measuring something he can't see, but he knows all about it, though, right?
Yeah.
No, he doesn't. He can't see it.
It's within 5%.
Within 5% of the assumption of a geometric horizon that gives you an effective horizon. He hasn't measured it yet, mate.
He's measured the dip angle.
To the geometric horizon that he can't see. You see how we're going round in circles, ladies and gentlemen? You see, Al-Biruni needs a physical geometric sphere edge to measure. And according to these fundies in the trenches, he can't see it.
Well, it's not apparent. I mean, it's not...
It's not apparent, so he can't see it then.
Yeah, I'll go through it again. I mean, I think it was you who you picked up how I explained it, and you actually repeated the exact definition of the difference between an effective radius and the real radius, between the apparent horizon and the geometric horizon. You did really well last time. So, just in case we don't know about this geometric horizon business, it doesn't look like a normal horizon, but it is a place that you can see, but it doesn't look like a horizon. So that's why I wasn't contradicting myself when I said you can't see the geometric horizon as a horizon.
It doesn't look like a horizon, Compass?
Sorry? Say again?
What he's asking you is, how can something that is let's say an elephant, not look like an elephant? And you're saying it is a horizon, but it does not look like a horizon. So what does it look like?
Because... it'll just be where the geometric horizon is located by maths. But what we see is the apparent horizon.
So it is just where the geometric horizon is located with maths. So it's not a physical location at all.
It is a physical location.
Sorry, you just said it's a location that's identified by maths.
But it's a physical location.
Okay, so can you show me what it looks like if it's physical, please?
It looks like just a bit of water with which you can see beyond. It does nothing. It doesn't look special in any way. It's just a physical location.
So when you say you can see beyond it, my understanding of a horizon is that it demarcates where land or sea meets the sky. So beyond this horizon, there's the sky, right?
Yeah, well, that's your misunderstanding of what a horizon is, yes.
Explain to me what a horizon is. A real one.
There are about 4 horizons. There's the geometric, there's apparent, there is astronomical, and there is a topological one, which basically... So if you have trees and things, sometimes that's referred to as horizon. If you've got some mountains or something, there's another described as horizon. I think in the National Geographic thing that QE read out, I think they referred to that as the geographical horizon, not the geometric. So there are about 4 or 5 different definitions of horizon, but the one that we tend to like to think about, where the sky meets the water, obviously not a mountain because that sort of confuses the issue, but where the sky meets the water, that's the apparent horizon. That's what we would talk about horizon casually, but that's not the geometric horizon because, of course, refraction means it's moved away from where the geometric horizon. You can still see the location of the geometric horizon, so you can still see something that's the geometric horizon, but it doesn't look like a horizon. It just looks like a normal bit of water that you can see, and the apparent horizon is beyond it.
So it just looks like a normal... Hold on. It just,
okay, go on.
Just looks like a normal bit of water. So you think a horizon is not a demarcation between, say, something that's in the near foreground. So if I put my hand in front of my face and I draw out a line with my hand, that could be a local horizon. Let's call it that. It's not the geometric horizon that we should see if we're on a ball. It's a local horizon that I've created myself. There's also an astronomical horizon, which would be 90 degrees from your zenith, which would be a fictitious horizon that doesn't exist. So then we're left with the demarcation between land and sea, which by your standards on a globe is described as the geometric horizon. And it's described and defined as a visible location that demarcates land and sea based on your globe, Earth, religion.
No, that's the apparent horizon.
So we do not see a geometric horizon, and so it's definitely not visible. It's always just a piece of water that doesn't demarcate anything.
Correct. Yeah, you got it. Well done.
So it doesn't demarcate a point between land and sea.
Correct.
So if it doesn't demarcate the point between land and sea, is that ever? Is that always?
Well, if you, for some peculiar reason, you had non-standard refraction and you had an sort of inverted, sort of semi-sinking refraction, then you would actually have the geometric and the apparent horizon same. Or if you went up very high and you were looking down, they would come close to one. They still wouldn't be the same, but they would get closer to one another. But because we have an atmosphere, because we have refraction, they very rarely coincide. They can get close.
What would coincide? Sorry, I'm a bit confused. What would coincide? What exactly is going to coincide with what? Because you're saying that the geometric horizon isn't visible, can't be seen, it just looks like water. It's not demarcating anything between anything and anything. I just want to clarify that first of all. It's not visible, it's not demarcating anything. The geometric horizon's only derived from maths, correct?
Correct.
So if it's only derived from maths and it can't be seen, it is not visible, how is it going to block a boat?
It doesn't. The effective horizon does that as a result of refraction because you can see further due to refraction.
So the geometric sphere edge horizon does not block boats and buildings in the distance?
The geometry of the Earth blocks things in the distance.
Well, that would be a geometric horizon, a physical sphere edge. That would be the tangent point getting in the way then. So now you're saying we do see the geometric horizon blocking boats and buildings, even though it's never visible, can't be seen. I'm summarising how you die, and you seem to be talking through me. What's going on? We were really civil until my demolition of your double speak that you've contradicted yourself with, and now you're interrupting me again. It seems Rumpus can't debate. I'm now going to try. This is a third attempt. We'll count him off. Fourth attempt. He's getting further away from me summarising his contradiction. I clarified with you 3 separate occasions that we cannot see.
You misunderstood me.
That's the 5th interruption. I'm going to summarise your contradiction. But because Rumpus needs a little bunker where he can talk over everybody that summarises anything that he's contradicted himself with, he will interrupt continually because that's what he needs when he's losing. So I'm just going to point out that he's losing and preventing me from summarising how he's contradicted himself by continually interrupting me. It's now 6 times. 7 times he's interrupted me. 7 times. So, if it's never visible, cannot be seen, is not optical, only exists in maths, it cannot block boats and buildings because it can't be seen and is not demarcating land and sea. So, the geometry, as you phrased it, of the Earth can't be blocking anything in the distance. That's the 8th time it's interrupted me. I'll try and summarise it. Do you need a neutral platform? It's the 8th attempt of me summarising your contradiction. Do you need a neutral platform? Need a neutral platform, do you, to obfuscate this? Neutral platform needed, maybe. Maybe tell me that you've only got 3 words. Go on.
When is it my turn?
When I finished. Right. When I finished summarising your death by pointing out that you've really given clarity to us not seeing something that does not demarcate land and sea and only exists in mathematics. Now, given that we can't see it, it doesn't exist, it doesn't demarcate anything, and only exists in maths, it therefore cannot block boats and buildings. Now, when I point that out, you say, well, it's the geometry that's blocking boats and buildings. Yeah, that would be a geometric horizon then. So it can't be both. That's a contradiction, Rumpus.
Because the geometric horizon, because of refraction, is not the thing that's blocking you. It's the effective horizon. So, which is
But you
part
said
of
it
the
only
geometry
exists in
because-
math, Rumpus.
Yeah, it only exists in maths.
You
but
just told us that.
You told us that the geometry of Earth is getting in the way, but we can't see a geometric horizon. It makes no sense.
I'm in mid-sentence. If you let me finish the sentence, it'll all become clear. The geometry of the Earth is refracted. So that becomes the effective horizon. That's not the same as the geometric horizon. The geometry of the Earth and the geometric horizon are not the same thing.
I see. Okay.
Thank you.
Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you.
5 more seconds.
Thank you.
5 more
Thank
seconds.
you.
Please, my 5 more
No, so I'm not going to get a chance to respond. It's just going to be 10 minutes of you saying 5 more seconds, is it? You've made your point clear. You've said the horizon is refracted. You've made your point clear. Now I'd like to respond without you constantly saying 5 more seconds. Thank you. So, what type of refraction is refracting the horizon?
Well, it's usually just standard refraction, but you can obviously have looming as well. But the usual form of refraction, you would expect
standard refraction, that's got an R value, and the R value would give you a tangent point. That's geometry. You understand the R in terrestrial refraction is utilizing geometry of the R value that we cannot ever see and is only existing in the maths. So it exists in the maths before it's refracted something with mathematics. You see, given that geometry and this horizon is only in existence in the maths, that maths can't refract things. Your standard refraction uses maths, not atmosphere. It uses R.
Which reflects
7
reality.
It's second attempt, maybe. Second attempt, maybe. Need a neutral platform so that I can't say this? Yeah, you need a neutral platform so I can point out that your refraction uses R. So it's mathematical based, not atmospheric based, and R gives you a geometric horizon, a tangent point. It's geometry based. And we can't see this geometric horizon. So this is circular reasoning, a logical fallacy, where you assume your outcome, that would be Earth's a sphere, and then you use the premise that you're assuming to prove that you're on a sphere. So in this case, you're assuming a geometric horizon that we cannot ever see, and then you're saying, no, we can't see it, but it's refracted with geometry, something that we can't see. So we've got an assumption of geometry, an assumption of mathematical, claimed to be refraction, actually 7/6R. The geometry, the maths, not reality, not refraction.
Reflects reality, yes. It reflects the refraction, the bending of light. It reflects the fact there's an effective horizon that's not the same as the geometric horizon, and the effective horizon is caused by two things: the geometry of the Earth.
Sorry, the geometry would need R. So you're saying the effective radius is affected by the geometry, and we can't see that. It only exists in maths.
Well, you can see it. I say if you go up high, you can reduce it to the point where the geometric horizon and the effective horizon are the same.
Chocolate, can you shut up? Chocolate, shut up. Sorry, Rumpus, you were interrupted.
Right, so if you go nice and high, like Al-Biruni did, and you look down, the geometric horizon and the effective horizon become very close to one, within about 5%. So if you decide to measure the radius of the Earth, you can do that using the Al-Biruni technique, and you'll get a value within 5%. But the effective horizon and the 7/6R is because the atmospheric refraction is a function of the radius of the Earth. That doesn't invalidate it, and there are obviously lots of other ways of measuring the radius of the Earth, so we know that it's correct. We know we're allowed to use R, and we know that the refraction is a function of the radius.
So Al-Biruni was measuring which horizon?
The dip angle to the horizon, yeah.
No, not the dip angle to the horizon. I asked which. You said there were several.
Oh, sorry. Okay, I missed that, but I didn't hear. Right, yeah. Al-Biruni was measuring the dip angle to the effective horizon, but because the effective horizon from a high altitude is very similar to the geometric horizon, he then got a value within 5% of the right answer because they are close to one another when you're up nice and high and looking down.
Is the effective horizon based on the geometric horizon?
Yes.
So he was presupposing a geometric horizon, or was he trying to measure the geometric horizon? I'm a bit confused. If he's measuring something that he hasn't yet measured, he can't derive that he's got a geometric horizon based on an effective horizon, because that would be assuming it's a geometric horizon to begin with now, wouldn't it?
Yeah, he was trying to measure the geometric horizon, but...
Oh, he was trying to measure the geometric horizon, but you've made it explicitly clear that it cannot be seen and only exists in maths.
I'm trying to answer. He was trying to measure the geometric horizon.
Yes, I understood that. He's trying to measure a geometric horizon, something that you say we can't see. It's just some point that doesn't demarcate land and sea. It's not a demarcation between land and sea, so how can he possibly be measuring it? I don't really understand how something that cannot be seen and only exists in maths anyway is going to be measured by Al-Biruni. Can you explain that?
He got an answer within 5% of the right answer.
Got an answer within 5% of the assumption that he's got an effective radius based on a geometric radius he's yet to measure.
I didn't hear what you said. You were interrupting me.
Oh, my bad. I was interrupting you when I was pummeling the fact that he's measuring a point you've said we can't see, a geometric horizon. But you're saying it's within 5% of an assumption of an effective horizon based on a geometric horizon he's yet to measure.
Yeah, it's within 5% of the
of a horizon that's geometric, that can't be seen. It's in 5% of something that can't be seen.
The effective horizon is what you see. The geometric horizon is just a position, doesn't demarcate anything, but it's close enough.
So it doesn't demarcate anything. We can't see it, but Al-Biruni was trying to measure it, correct?
Yeah, he was trying to find...
Yeah, so he was trying to measure something that he couldn't see. That makes no sense.
But it was, because he knew it was close to...
He knew it was close, so he's measuring something he can't see, but he knows all about it, though, right?
Yeah.
No, he doesn't. He can't see it.
He knew that
Sorry, don't tell me what he knew. He's supposed to be measuring something. Why are you telling me about what he knows? He's supposed to be measuring it.
He did measure.
Sorry, he can't see it. He can't see the geometric horizon to measure it. He can't possibly be...
You can see the effective horizon.
Sorry, he just told me he's measuring the geometric horizon. The effective horizon is based on a measurement of the geometric horizon and the differential based on that presupposition. He hasn't measured it yet. He can't be comparing it to an effective horizon. He's measuring a geometric horizon, and you've said you can't see that.
No, he's measuring the effective horizon.
And what's the effective horizon? Is that based on the geometric horizon? Yes, it is, Nathan. This is the second time we've gone round in this circle now, isn't it? Why would we be going round in circles already? He's trying to measure the geometry, isn't he?
You can't think. The dip angle is independent of anything. That dip angle gives you the dip to the apparent horizon.
To the apparent horizon? But that's not the geometric horizon, so he wasn't measuring the geometry then.
He was measuring...
Sorry, he just said he was measuring the apparent horizon. That's not geometric. So you're saying he was measuring the apparent horizon. He's not measuring geometry then?
He is, because it's...
No. Apparent isn't geometric, moron.
It is, you moron.
It is. You think apparent horizons... You've just made it really clear these are different things. You stressed to me how different the apparent horizon was to the geometric and how it absolutely was not the geometric. Now you're saying he's measuring the apparent horizon. So he's not measuring geometry, Rumpus.
It's within 5%.
Within 5% of the assumption of a geometric horizon that gives you an effective horizon. He hasn't measured it yet, mate.
He's measured the dip angle.
To the geometric horizon that he can't see. You see how we're going round in circles, ladies and gentlemen? You see, Al-Biruni needs a physical geometric sphere edge to measure. And according to these fundies in the trenches, he can't see it.
Well, it's not apparent. I mean, it's not...
It's not apparent, so he can't see it then. So he's measuring the geometry of something he can't see then.
No, he's measuring the geometry of the effective horizon.
The effective horizon's based on the geometric horizon. So he's measuring something based on a presupposition of something he's yet to measure. No, Rumpus. he's measuring a geometric horizon, something you say isn't apparent. Then when I point that out, you say he's measuring the apparent horizon, something that's not geometric.
How about letting me answer? Right. So when you measure the dip angle...
To what? What are we measuring the dip angle to? Let's get some clarity. Take it a step at a time. What's the dip angle to?
Give it a try, Nathan. Let me actually answer instead of interrupting me off.
Okay, I'll ask the question. What is the dip angle measured to?
Not let me answer, will you? How about letting me answer? Give it a...
Okay, I'll let you answer. I'll ask the question, then I'll let you answer. What is the dip angle being measured to?
Sorry, I missed the... Can you say that again, please?
You're asking me to ask you for a fifth time? Yeah, I don't mind. What's the dip angle being measured to?
The effective horizon.
Based on the geometric horizon.
Not the geometric horizon, no.
Not? So he's not measuring geometry then?
He is measuring geometry, yes.
So that would be a geometric horizon then?
No, it wouldn't, because...
So the geometric horizon isn't what you measure when you're doing geometry. You seem to not understand what geometry is. You don't understand what geometry is.
Answers here. I know that's what your tactic...
You're telling me he's not measuring something geometric? Well, then he's not doing geometry, and you're telling me I, don't understand this? Either he's measuring geometry or he isn't. He's either measuring something that's got geometry or he isn't. It's just that simple. If he's measuring an apparent horizon, as you say he is, that's not a geometric horizon.
How about letting me answer, Nathan? Right, so you asked me what he's measuring, and he's measuring the dip angle as he sees it optically, and that will give you the dip angle to the apparent horizon.
The apparent horizon's not geometry then. So he's not doing geometry. The apparent horizon isn't the geometric horizon.
Let me finish a sentence, will you, Nathan? Right.
You did finish a sentence. You said he's measuring to the apparent horizon. Well, the apparent horizon isn't a geometric horizon. So he's not measuring geometry. It's just that simple. Now, I realise that it's obviously in need of obfuscation, but you've made it clear what an apparent horizon is, and if he's measuring to that, he's not measuring geometry. Now, you don't have to like it, and communication shutdown won't work here. I've told that you many times. But if you're saying apparent horizon, and I'm absolutely certain based on your definition that apparent isn't geometric, then he's not measuring geometry then, is he?
Scaredy cat. Scaredy cat.
So is that your rebuttal? If he's measuring an apparent horizon, he's not measuring a geometric one.
I haven't been able to say yet, actually.
All you've done is tell me how you've not been able to talk every time I've responded by pointing out that, as you've explained, and I heard, I asked you what he was measuring, what the dip angle was measured to. You told me it was measured to the apparent horizon. Well, the apparent horizon, you've explained, is not geometric. So he's not measuring any geometry then.
Scaredy cat.
That's the same rebuttal. Every time I repeat that he's not actually doing geometry, if he's measuring an apparent horizon, you tell me that I'm a scaredy cat.
End of my answers.
Nathan, he's just saying scaredy cat to everything you're saying.
Yeah, that's because he's stuck his fingers in his ears and he's a coward. Rather than letting the rebuttal be heard, he would have to respond to it if he listened to it. So talking through it is the order of the day. So he doesn't have to respond to it. And he can justify it because, according to you guys in Discord, he's just saying scaredy cat over the top of me pointing out his problem. Now, he doesn't like that. Of course, it's the end of his argument. So the only thing in rebuttal, he hasn't got one, by the way, is to obfuscate the point. That's the only thing he can do from here on in.
So let me finish the sentence. See what it's like. See what the debate's actually like.
Okay.
Right.
Can I ask Rumpus a question?
When Al-Biruni measured the dip angle, he was measuring the apparent horizon.
That's not geometric. So if he's measuring an apparent horizon, then you've clarified that that's not a geometric location. He's not doing geometry, Rumpus. Now, I've made that point clear, and you've told me that I'm a scaredy cat.
Frightened.
You say it's the same thing again, ladies and gentlemen. So I've pointed out that if he's measuring an apparent horizon, as defined by Rumpus, that's not geometric. Therefore, he's definitely not doing any geometry. That's pretty much clear.
Scaredy cat. Right.
Yeah, that's an excellent rebuttal. He's not doing geometry.
How does he know he's off by 5% if he didn't have a geometric horizon to measure that to?
He's shut down, basically. He's decided that the only rebuttal he'll give to our concise demolition of the claim that Al-Biruni measured the radius by way of a dip angle measurement to a geometric location has been undone by Rumpus saying he's measuring an apparent location. Ergo, Al-Biruni was not measuring the geometric value of R. He was measuring an apparent location that is absolutely not geometric by Rumpus's own definition. So therefore, it's the end of his argument. Now, he can't let the audience know that, so it's scaredy cat as a rebuttal.
Scaredy cat. Scaredy cat.
See? Scaredy cat. Not, oh yeah, that's right, an apparent horizon isn't geometric, therefore he's not doing geometry, because that will end the assertion that Al-Biruni established R with a dip angle measurement to the geometric horizon he can't see.
Scaredy cat.
Excellent rebuttal.
Come back, Litter. Come back,
This
Litter.
is better than
Rumpus.
mute.
The effective
It's just
rate
established.
of horizon,
Hold on, let's
apparent
just see if I
horizon.
can find out. I don't mind if
And
he sticks his
then
fingers in his
he
ears.
then
at this
decided
point,
to use that
I'll just find
value
out
as
from Neil. Neil, did you at any stage hear my rebuttal in regards to Al-Biruni, or was it all cut off by Rumpus so that he could claim he didn't hear it?
No, all he did was kept saying scaredy cat, over and over again.
So in other words, just for the audience's benefit, so that Rumpus didn't have to respond to the demolition of his argument. That is to say that in order to measure the geometric R value by way of a dip angle measurement to a geometric horizon, you're going to need to see a geometric horizon to measure a dip angle to it. Now, he's claimed he's measuring to an apparent horizon. And the apparent horizon, we're being told by every person in the globe Earth community, is not the geometric horizon. So he's not measuring Earth-based geometry. That's the end of Rumpus's argument. We don't have a geometric horizon, and you're going to need one if Al-Biruni's measuring to it to get an R value. This is why you haven't got R! Your globe maths is dead, fundies, and your rebuttal is scaredy cat!